Good Monday morning. I am MPJ and you are watching FunFunFunction. This week's video is going to be about unit tests versus integration tests. I would like to start talking about automated tests in general. When you first start out doing software development, one of the first concepts that you're going to be very aware of is bugs. You start writing some piece of software and it works fine, but you didn't quite think of this thing, so you fix that, and then you test around a bit, and I need to fix this case as well. And after a while, the application grows, and there are quite a bit of test cases that you have to go through every time you make a change to make sure that you didn't break anything. A fancy word for that is regression testing. You basically check that your software has not regressed, that a feature that previously worked now is broken, or maybe it has started working in another way, which the user will not like. So let's say that you start out doing your regression testing manually, because your app is small, it doesn't have a lot of features. It's basically perhaps 10, 20 test cases that you have to go through every time you release. But as months go by and you do active development on your software, that number grows. It grows from 20 cases to 30 to 40, and you're probably up in the hundreds after a couple of months at least. By now, you might have created an Excel sheet that tracks all the manual regression testing that you have to do. And every time you do a release, you walk through this spreadsheet and you do the manual testing. And each test is surprisingly complicated to do, because you have to create this fresh user and simulate a fresh state in the application, and then work from there. And even if you have a nice tool for creating test users that can do that quickly, and setting the application in a certain state, this ends up taking at least a couple of minutes per test case, which means that you're basically having at least a person, or maybe even a couple of persons, spending more than a day on doing just the manual regression testing. And then, to make things even more complicated, you realize that your customers have different environments where they run your app. For instance, they might have different operating systems, or different devices, different mobile phones, or they might be running them in different web browsers. And this affects your tests. So this list of your 100 regression tests is actually multiplied by the number of operating systems you support, and also multiplied by the number of devices you support, creating this combinatorial explosion. You find that even if you have full-time people employed just to do regression testing, you will find that they are overwhelmed. And if they're not overwhelmed, they will eventually be overwhelmed, because this list of 100 test cases will keep growing. That is just the way software works. It's very rare that you remove features from software, at least compared to how often you add things to software. So the answer to this problem is, of course, to have machines do the bulk of your regression testing for you. You cannot completely replace human testers with automated tests, partly because there are some things that only humans can see, and also because test cases needs to be invented in the first place, and humans are way better at that than machines, doing so-called exploratory testing. But the bulk of your regression testing can and should be done by machines. What I want to say here is that automated tests is absolutely critical to the production of quality software. So this might be harsh to say, but if you don't use automated tests, I am willing to bet quite a bit of money that your software isn't very good. If we are building software that people are relying on to work, we must have automated tests. next up, I'm going to define what I mean by a unit test and an integration test, because there's a lot of confusion and different usages of the terminology when it comes to automated testing. And first, we're going to talk about the definition of a unit test. So let's say that you are building an application. Applications normally has at least some attempt at an architecture. Your application might have like, let's say that this is a view layer. View. The view might have some other layer that it's interacting with. Let's call it the controller, but it can be anything. Like, some people call it model, some people call it logic. Somebody might call it core. These are just words. There's no official definition or anything for them, even though some people might give you the impression that there is. And then maybe you have some kind of database. Your controller is writing and reading from the database. And maybe you have some payment system as well. This is code that is generally written by you, and this is external components. The view of your application might be built out of multiple smaller parts that we might be calling components or modules or whatever. If you're using React, for example, these would be your React components, the things that you define with JSX. And in the same way, your controller or business logic layer or whatever is also made up of multiple smaller parts. If you're using Redux for this layer, for example, these components would be your action creators and your reducers. The exact terminology isn't important, really. The important takeaway here is that your application is made out of these parts, whatever they may be, these units that we can write unit tests for and test in isolation. The unit tests that we write, they are only concerned with this friend here. This part, it interacts with the payment system, and it's being used by a couple of components in the view. But when we're unit testing, we are not concerned with this system or these systems. We're only concerned with this system, this part. So what we do in our unit test is that this input here, we're not actually using real inputs. We are just putting in fake inputs into the controller. And in the unit test, we're not giving this part a real payment system. We are giving it a fake payment system, a so-called mock payment system that we expect this part to perform certain actions on, and then we inspect our fake payment mock spy thing to see what calls have been made on it, and then just verify that this part did the right thing to it. By the way, if you're interested in learning more about the concept of mocking, I have made a video about that you can find in the episode description. This message was brought to you by former MPJ. The takeaway here is that testing these things, these parts, individually and isolated, that is the definition of a unit test. Okay, so with that in mind, what is the definition of an integration test? A disclaimer here is that multiple people are going to give you different answers to the question of what an integration test is. I'm going to give you one. So remember our hypothetical application from before. When we write an integration test, we are writing a test that is concerned with the entirety of the application, or at least multiple components. We might write an integration test that looks like this, that covers some component in the view and some component in the controller, or whatever you call this, and that also touches the database. In fact, the integration test might even cover multiple controller components. An example of an integration test might be something that just punches through the entire application. For instance, might to go to the item page and put an item into the cart and then view the cart. These things, they touch a lot of stuff. Unlike the unit tests, these things, the integration tests, they tend to use a real database that you set up and spin up and create for the integration test. You can't actually use the real database and the proper real payment provider because then you would be making payments and stuff each test you run. But they are like very heavy fakes. Like it's probably a real database that you're spinning up and populating with sample data, for instance. And up here, it's probably something that looks like a real browser, such as something that is controlled with Selenium or maybe a FunFunJS thing. Up here is something that very much looks to the system like a real user that goes around clicking in the application. That is how I define an integration test, something that touches multiple components in one fell swoop. You don't necessarily have to use real databases and stuff. Some parts of an integration test might be mocked. Integration test, it's a fuzzy definition, but for this video, it's a test that touches multiple components. Now that we have defined what unit tests and integration tests are and what they do, let's talk about the downsides of unit tests. There are two downsides to unit tests. And the first one is that they do not test the contract. What does that mean? Well, these view components here, they expect the controller to look a certain way. They expect it to have methods and properties and, stuff. Like they expect this call to look a certain way. In the same way, this part here expects a payment system to look a certain way. They might expect the payment module to have, like a method called pay, whatever. This is sort of the contract between these parts of the application. This contract needs to be in place for us to be able to do unit testing, and it's what we exploit to do it. For instance, when we pass our mock payment service into the this part here, we make sure that mock payment service implement the same contract or interface or whatever you would like to call it as the real payment service. This controller part, it doesn't really care if it's being passed a real payment service or a mock payment service. The important part is that it implements the payment contract. In statically typed languages like Java, you would probably solve this by having the payment service and the mock payment service both implement like the payment service interface. But in JavaScript, we don't have to do that. We just make sure that they have the same methods to call. And this is the weakness of unit tests, because they don't test this interaction. The unit test will test that these parts, the view parts, make a certain call to the controller, and the unit test of the controller tests that the controller does certain things, such as calling the payment system based on inputs that it gets from the view. But this is all based on like the assumption that we're getting the contract right in both tests. For example, if we make a mistake implementing our payment service mock, or if we make a mistake when we write the fake inputs into the controller, our test will not catch these errors, even though all the unit tests pass. An integration test, on the other hand, it will just go, it's not concerned with this at all. It just tests the application straight through, and yeah, it will catch those errors. That's the first downside of unit tests. It's that they do not test the contracts, but integration tests do. The second downside with unit tests is that you have to create contracts. When you start writing unit tests in your career, it's just gonna annoy you that you find yourself that you have to write new boilerplate just to make your code testable. These contracts that I talked about, like these interactions here and this separation, it has to be there in order to write unit tests. If the payment system is not cleanly separated from the controller parts, for instance, if you say that you just have the payment system inside of these parts and call it directly, then it's not really possible to write a unit test because, well, it's just not a unit, it's just stuff jumbled together. This is not a problem that integration tests have. They just test the application and then they inspect the database. It does not matter to the integration test if these parts are not properly modularized. It just goes through and checks. I talked before that in statically typed languages you would create an interface that both the payment service and the mock payment service inherited from or implemented. That is a problem that you probably, to be honest, only have, and it's code that you only have to write because you want to unit test your code. And you also have to create mechanisms in order to get your mock payment system into the controller parts. This is the mechanism that people talk about when they refer to dependency injection. While it is annoying that you have to create these layers of separation, it also is a benefit because it forces you to modularize your code. If you have code that is modularized, but you have not previously been writing unit tests, you will probably find that when you do that, your code is not at all as modular as you thought it was. It's actually pretty jumbled together and not cleanly separated at all. And writing unit tests have helped you expose that problem. But it is work, you have to do it in order to do unit testing. Like, unit tests have definitely the downside that you will have to create these contracts. Now, at this point in their careers, a lot of developers, almost all developers actually, find themselves asking, can't I just use only integration tests? I mean, integration tests seem to test all of this, and they don't seem to have any of the drawbacks of the unit tests. Well, couldn't we just use integration tests to test all of our app? Then we just have real databases, we don't have to bother with this mocking, we don't have to bother with dependency injection and making being afraid of making mistakes in our contract. Why don't we use just integration tests? And almost all developers do try to do that at some point in their career, but they will then learn that there are downsides to integration tests as well. The first one is that integration tests are more expensive than unit tests. The second problem with integration tests is that they cannot simulate errors. And the third downside with integration tests is that they don't tell you where the problem is. What do I mean by expensive? Integration tests are expensive in 3 ways. And the first way that integration tests are expensive is that they are slower to run. In order to facilitate this thing, you need to spin up a real browser and you need to spin up a real database. If you're careful, you might be able to do this relatively fast. Like if you have some kind of database that is very quick to create and tear down. MongoDB is, for instance, very good at this. You can do it in just a couple of hundred of milliseconds. And if you have not a full-fledged browser, but a browser like FunFunFunction, which is also pretty fast to spin up, then you can run them reasonably quickly. But no matter how you cut it, they are very, very, very slow running compared to this thing. You can easily run hundreds of unit tests in the time it takes to run a single one of these. This makes a lot of difference because while you are developing, you want to be able to run the test as fast as possible, preferably every time you hit Command Save. And if you have tests that takes seconds or even minutes or maybe even hours to run, You're not going to do that. You're going to defer that to like the build process, and maybe it's even going to be too slow for even your build process, so you start deferring it to even later. You really want a test suite that you can run quickly and not something that will take hours. So an integration test is often hundreds of times slower to run than a unit test. The second reason why integration tests are expensive is that they are pretty brittle. So integration tests, they cover a lot of systems, which is in one way is good, but there's also a lot of moving parts here. You have a browser, you have all these systems, and you have a database that you're tearing up, tearing down. These systems might also be on separate networks, so you have like a network aspect to them as well. And the more of these little things that you introduce, the more things there are that can go wrong. And because we run these things thousands of times, and because statistics, more things will go wrong. Anyone who has written these things, they know that these things are very, very hard to get to run with 100% reliability. So integration tests, a lot more brittle than unit tests because there are a lot more moving parts. The third and final reason why integration tests are more expensive than unit tests is that they are simply harder to write. At first glance, it seems easy to write a unit test that has, yes, remote controls a browser and clicks around in your app and then inspects the database. But in practice, it's really complicated because you do this thing and you just realize that, nothing is working. And I don't really know why. It's just silently failing. Like I do these clicks and it's not ending up, I'm not getting the correct output in the database, and the error is somewhere in this application, and the application is huge. These things usually have some kind of screenshotting functionality that you can use for debugging, but it's often hard to get stack traces and stuff out of these things, and perhaps you can add logging to this system, but then you have a problem getting that out, and also coupled with the fact that there's a lot of system as here, and sometimes things go wrong, which means that you have intermittent problems and you have no real way to figure those intermittent problems out unless you add some kind of logging infrastructure. Integration tests require a lot more work and skill to write than unit tests. It's an order of magnitude harder. Because integration tests are so expensive, you simply cannot create enough of them to test your entire app. If you're actually trying to cover all of your possible test cases using integration tests, you will find yourself just paralyzed with the amount of time and effort that it requires to debug and maintain and write your integration tests. They are simply too expensive to use for all of your testing. But that's not the only downside with integration tests. There's also the fact that integration tests cannot simulate errors. If we go back and look at our sample app, your system needs to be error resilient, right? If the payment provider for some reason is down, your application cannot simply crash. It needs to be able to handle that error gracefully. Or the database might have a network error, or it might be a network error here between these. Like, you need the ability to fake errors. And unit tests really shine at this. This is very hard to do in an integration test. It might even be impossible depending on what your setup looks like. Simulating errors is actually one of the really good arguments for unit testing because it's also one of the things that manual regression testing, like human-based regression testing, is also very bad at. So unit tests are almost your only line of defense against those errors. But the most troublesome downside with integration tests is that they don't tell you where the problem is. I touched on this a little bit before when I talked about how integration tests are hard to write. When you run a test, like an integration test, and it fails somewhere, sometimes you're lucky and you get a stack trace with a clear clear description on where the error is, but more often than not, it's just gonna fail, and it's gonna fail in a cryptical way, which sends you on a wild needle in a haystack chase through all of these systems trying to find out where things went wrong. This is even worse if the error is intermittent, because then you can't actually deterministically run it and debug the application. You have to rely on logs, and then you need to have very good logging in your integration test framework, which you usually don't have because that's hard. So we cannot simply replace unit test with integration test because of the downsides of integration tests. Integration tests are expensive, they cannot simulate errors, and they don't tell you where the problem is. You have probably figured out the moral of the story already, but you need both integration tests and unit tests. When discussing these things, young developers, Jesus, that sounded arrogant, but it is often young developers, often pose the theoretical question like, but if you had to choose, which is more important, integration tests or unit tests? It is like asking, which one would you prefer to have removed, your heart or your brain? Well, the brain needs the body, but no, they are both needed in order to create quality software. You cannot skimp on one of them. Anyway, let's summarize. We've talked about unit tests versus integration tests. I spent some time talking about why automated tests are critical to produce quality software. I presented a definition of unit tests, and I then presented a definition of integration test. I talked a little bit, I showed you this, I talked a little bit how unit tests are testing these things, your parts of your application in isolation, while integration tests are more like cutting through the entire app, touching many different systems. Talk a little bit about the downside of unit tests. One was that they don't test contracts. Talk about how contracts are the communication between your application parts. The second downside to unit tests is that you have to create those contracts in the first place. And finally, I talk about why you can't simply replace unit tests with integration tests because of the downsides of integration tests, which is that they are expensive, they cannot simulate errors, and they don't tell you where the problem really is. If you like this video, please do share it with a colleague. If you are that colleague, welcome! You have just watched an episode of FunFunFunction. I release these every Monday morning, 0800 GMT. Please press below and check out the channel and see if it's something that you like and maybe even subscribe to. I am MPJ. Until next Monday morning, stay tuned.